Okay, ladies and gentlemen, in this video we're going to talk about squares and square roots. We're not necessarily talking about the shapes right away, we're essentially talking about the exponents. We're talking about raising something to the second power. So when we say that we're squaring a number, that means the product of a number and itself. Meaning, for example, 4 squared. 4 squared would mean, that's an arrow, that would mean 4 times 4. Exponents mean repeated multiplication. The number of the exponent tells you how many of your base are you going to have. So I have 2 of 4s because that number right there is a 2. So when we say squared, that's just lingo, or that's just a shortcut, a fast way of saying to the second power. So 4 squared means 4 times 4. And 4 times 4 equals 16. So that's what we say when we're squaring something. Now, what I want you guys to think of is this way. Whenever you're going to go in the opposite order, like let's say 4 squared is 16. But let's say I now ask you, well, what is the square root of 16? That symbol, that radical symbol, the radical sign, it's not a check mark. It's essentially just a little, we call it it's like a grouping symbol, like parentheses, but it means an operation. That means what's the square root of 16? When we say square root, we're saying go backwards. We knew that 4 squared was 16, so we're asking ourselves, what times itself equals 16? Well, that's going to be 4. So the square root of 16 equals 4. Now, technically it equals positive and negative 4, but right now in 7th grade math, we're just going to keep it simple. We're just going to say it equals positive 4. So the square root of 16 is 4, because 4 times 4 equals 16. So that's a square. Squaring is to the second power, and this is the square root, going backwards. So just like before, with adding and subtracting being inverses of each other, meaning they undo each other, they're the opposites of each other. Multiplying and dividing undo each other, they're the inverses of each other. Well, squaring and square rooting, they are the inverses of each other. They undo each other. So that's kind of what we're going to talk about. And in the beginning of this video, we're only going to talk about perfect, pretty squares. Meaning numbers that have nice square roots. But after that, in the same video, I'm combining 2 sections. We'll talk about what do you do with when it's not a pretty perfect square. So you've heard me use this word, pretty perfect square. Let's make sure we understand what those are. A perfect square, let's list the easy ones, okay? The perfect square are numbers that are a result of something times itself. So perfect squares. They go on forever, but let's just list a few of them. So let's start at the bottom. 1 times 1, 1 squared. Well, that's just 1. 2 squared, or 2 times 2, that's 4. 3 squared, or 3 times 3, that's 9. 4. 4 squared, 4 times 4, that's 16. 5 squared is 25. 6 squared, 6 times 6, well, that's 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. Now, sometimes we get a little stuck after these, but maybe try to know a few more, but at least know these. 11 squared, 11 times 11, that's 121. 12 squared is 144. 13 squared is 169. And I'm going to stop there, just I'm out of room. But really, you don't have to memorize all of them, but it does help you to recognize them. It's going to speed you up with some things you're doing later. For example, when going through these problems and doing square roots, a lot of them are going to be these numbers. They're going to be these perfect squares. So you know that the square root of 36, well, that's 6, because 1, 2, 3, 4, 5, 6. So the square root of 36 is 6. The square root of 81 is 9. The square root of 9 is 3. The square root of 121 is 11. The square root of 25 is 5. The square root of 4 is 2. So when you know them and you recognize those easy, perfect squares, it's really easy to find the square roots of those numbers. It's really fast and easy. Excuse me. So if you wanted to find a square of 5, as a reminder, that means 5 to the second power, which means 5 times 5, which is 25. If you're going to use a calculator to help you with that, that's the same thing you're going to do. Now, scientific calculators actually have a squared button, but in terms of 7th grade math, we want to make sure you understand the arithmetic of this operation. So we're going to require you to use a basic 4-function calculator. So you're going to do 16 times 16 to get the square of 16. Find out 256. So that's what we're doing in these problems. Those are squares and square roots. Now, what we're going to do is we're going to try a couple examples of just finding squares and square roots, and then we're going to talk about an actual shape of a square for a moment. So bear with me, we're going to do a couple examples to make sure we understand squares and square roots. Okay, so I left the perfect squares we wrote down before and the examples we wrote down. That way you can have them for reference. Hopefully you already wrote those down, but just in case. Alright, so in these instructions, find the square of each number. Well, 2 squared. Find the square of 2 squared? Well, that means 2 times 2, and 2 times 2 equals 4. So 2 squared equals 4. Or you could have said 1, 2 on that list of perfect squares. 8, find the square of 8 squared. Find the square of 8. So 8 squared. Well, that means 8 times 8, and that equals 64. That's all you have to do for these questions. Now, 11 squared. So 11 squared, that means 11 times 11. We said earlier that was 121. And now 15 squared. Now, like I said, not all of these you may know off the top of your head, so it's not shameful if you need to use a calculator. So for 15 squared, we're going to do 15 times 15, and that's one of those, that's 225. You'll get the knack for a few of them. You'll start to realize some of the common ones that you'll recognize. You also start to see patterns, like for example, 30 squared, so that's 30 times 30. That's one of the ones you'll remember because you know that 3 times 3 is 9, so just add 2 zeros, so 900. So you'll know what 30 squared is. So for a lot of them, there's also patterns that you can use using your number sense. So you can show off sometimes if you know those really big squares or square roots because you're seeing a pattern within them, or if you can at least estimate. Okay, now, finding each square root. Now we're doing the opposite, we're doing square root. So square root of 64. What times itself is 64? Well, if you remember from earlier, 8 times 8 is 64. So that means the square root of 64 is 8. 121, well, we just had that one up here. So the square root of 121 is 11. 81, we mentioned that when we did our list of perfect squares. 81, the square root of that is 9, because 9 times 9 is 81. Square root of 0, what times itself equals 0? Well, 0 times 0, that equals 0. So the square root of 0 is 0. So now, what you have now is we just did a few examples of squares and square roots. So now we're going to talk about the actual shape of the square. So bear with me, we're going to get to that. One moment. Okay, so look at example 5 at the top. It says a square tile has an area of 144 square inches. So they just gave us a tile, and they just told us what the area of this tile was. So here's what I'm going to do. To help you see this, let's start by drawing your best perfect square you can draw. Draw the most perfect symmetrical square you can manage. The more perfect, the better, because then it makes more sense. So I did that one by hand, and I'm extremely proud of it. I think my students would agree. A lot of my squares come out all janky and crooked. All right. Anyways, the area of this square is 144 square inches. So inches squared. Remember, that squared right there means that's the denotation. That's how we say we're talking area. We're talking square units. Meaning there are 144 little squares that are 1 inch by 1 inch filling this thing up. So I just drew a few of them just to give you an idea of what I'm talking about. So now I'm going to ignore those squares. I'm not going to use them. All right. So now here's what you're going to do. If they're asking you what are the dimensions of the tile, well, that might not always be obvious to you. If you know the area, what are the dimensions? Dimensions meaning what is the length and the width. So to help you understand this, let's draw a rectangle real fast. Now this rectangle has nothing to do with this question, but I'm going to draw it to make a point. Assuming that was a perfect rectangle, which it clearly is not. Assume it's a perfect rectangle. So now, normally to find the height, the area of a rectangle, normally find the area of a rectangle, we would do base times height. Or some people call it length times width. Whatever you want to call it. Base times height, length times width. That's how you find the area of a rectangle. Well, hey, a square is a rectangle. So it's just a perfectly symmetrical rectangle. So we're still going to do base times height, length times width. But here's the thing. On a square, all sides are equal. So that means the length and the width, or the base and the height, they're exactly the same thing. So we don't need to call them something different. So for a square, let's just call it S for side. Let's just call it side. So let's call both of them S for side. So that means length times width, or base times height, that's just side times side. So the area of a square, the area of a square is side times side, or base times height, but it's the same thing. So that's going to equal side times side. Well, that's side to the second power. Just like 4 times 4 is 4 to the second power. So that means the area of a square is just the side length squared. To get the area of a square, you just take the side length and you square it. You raise it to the second power. That's actually where the saying came from, squared, for that exponent to the second power, because that's how we find the area of a square. So if we know the area, we need to go backwards to find the side length. We got to go back to what we said earlier. What's backwards of squaring? And we said it was square rooting. So the backwards of squaring is square rooting. So that means if you take the 144 square inches, you take the square root, the answer is going to be the length of your square. It's going to be the length of the side. So that tells you this side is a length of 12 inches, which means this one has a length of 12 inches, which means this one has a length of 12 inches. So they all are 12 inches. So if you had a question that, maybe most of the questions will say, what's the side length? You'd say 12 inches. Some of them will try to trick you and they'll say, well, hey, what's the perimeter? Or what's the total distance around the shape? Then you would do 12 plus 12 plus 12 plus 12, or 12 times 4. So the perimeter would be 48 all the way around. So just be aware, make sure you know whether they're asking for the length of one side or they're asking for the total length of all sides. So anyways, if you know the side length, you square it to get to the area, and if you know the area, you square root it to get the side length. So that's what we just did. We square rooted to get 12. That's why we know it's 12 inches. So it's 12 inches by 12 inches. So because it's a square, you can just say the side lengths are 12 inches, or properly when we say dimensions, we're talking length times width, or the length by the width. So 12 by 12. That's the dimensions of this square. So now let's look at the question about the city park. Now in the city park, actually it's gonna be the same answer. I did it on accident, so we'll do the card table in both city park. So now the card table. The top of a squared card table has an area of 900 square inches. What are the dimensions of the table? Meaning that's the area of the square. So we're gonna have to square root that. Well, hey, you know the square root of 9, so that's 3. So this looks like it has 2 more zeros, so that means 30. So 30 times 30, is that 90? Oh, it totally is. So that means 30 inches. That's how long and wide this table is. So you could say 30 inches by 30 inches. That's the dimension of that card table. Take a moment to see if you can do the city park one doing the exact same thing. Okay, and the city park one is an area of 14,400. Well, if you ignore those zeros for a moment, ignore these, that's 144, that's 144. Well, we know the square root of that. Square root of that is 12. So the square root of 14,400, that's going to be 12 with 1 0 after, or 120. So that means the dimensions of this park are 120 yards by 120 yards. By 120, or just YDS for yards. So that's what we mean when we say find the side length if you know the area. Or the opposite. They may ask the opposite. They may give you a side length and ask you for the area. Alright, so in this problem, we're talking about geography. It says refer to the squares below. They represent the approximate areas of California, Alabama, and Nebraska. Find the area of Alabama. So take a moment, hit pause, see if you can do this one on your own. Now, quite a few students make the mistake when they do this. When they find the area of Alabama, it just said that they are squares. So a mistake I've seen in questions like this, students would do 225 miles by 277 miles. So they would do 225 times 277. But hey guys, 277, that's Nebraska's length. That's side length. Whereas the 225 is Alabama's. So Alabama is 225 by 225. Or, remember we talked about squares. The area of a square is the side length squared. So 225 squared, otherwise known as 225 times 225, that is the area of the approximate area of Alabama. So I do not know what those are multiplied by each other. So 225 times 225, that is 50,625 square miles. That is the area of Alabama. So make sure you read the question carefully. Make sure you're reading your visual diagram carefully when you go to do questions like this. Now, our next question says, refer to what we just did. And it says, how much larger is California than Nebraska? Well, if you take a look, California, you're told, is 395 miles. That's the side length. So that means the area of California is 395 times 395 again, or 395 squared. That's the area of California. And it says how much larger is California than Nebraska? Well, that means Nebraska, we're going to do, okay, Nebraska is 277 miles by 277 miles, or just 277 squared. That's the area of Nebraska. Now, make sure you're using the correct numbers. This is how much larger is it. So that means we're going to subtract. So now your job is just to see what this equals. Now, these are big, giant numbers. I don't expect you to know these are squared off the top of your head. We don't have to be crazy about this. So 395 times 395, well, that gives us a big, giant number. That tells us 156,025 minus, now 277 times 277, well, that's 76,729. Subtract this, now that's how much larger it is. So that tells us it's 79,296 square miles. I fit it. Okay, that's how much larger California is than Nebraska, approximately, since these squares are approximate. But that's how you find this. Find the area of the bigger square, find the area of the smaller square, and then subtract them, and you now know how much larger it is. So these are some examples. We're putting a lot of emphasis on reminding you how to read problems and how to find the area of squares or find the side length of squares, because that's going to help us when we continue later in this section and talk about the Pythagorean theorem. So keep this stuff in mind. We're going to refer to it. So don't think that we're just randomly talking about squares because we feel like it. It's a connection to what we're going to talk about with the Pythagorean theorem. So hold that thought. We're going to make this one our last example in this half where we're using pretty perfect square roots, because this one's going to kind of segue nicely into what we're going to do next. Because this one, you notice the very last sentence says round to the nearest tenth. So that's already telling us our final answer isn't going to be a pretty perfect answer, perfect square, because not every number in the real world are pretty perfect squares to where the square roots are really nice whole numbers. So in this one, let's actually read it, and this is, like I said, this is going to be a perfect segue into what we're going to talk about next, what to do when your square roots aren't perfect squares. All right, so this problem is about motion. It says the time t in seconds, so t is seconds, for an object dropped from a height of h many feet, so h is the height, to hit the ground is given by the formula time equals the square root of 2 times the height divided by 32. How long will it take an object dropped from a height of 500 feet to hit the ground? So I hesitated because I realized 500 feet, well, that's important information. We just found out that h was the feet in height. So we just found out the height was 500 feet, which means this h needs to become 500. So write that as a note to yourself. So essentially, h is the input. See what all this equals, and you'll have your output of time. So this is essentially an input-output type of function. Okay. So now, what we're going to do is let's make a note to ourselves. H equals 500 feet. So your height isn't going to be negative. Height is positive. 500 feet above the ground. So now we're going to rewrite this entire question, but instead of h, we're going to plug in 500. So t equals giant square root 2 times something divided by 32. So now plug in the 500 in h's spot. There used to be an h here, now there's a 500. So that h is now 500. Now, here's how the order of operations works with these. I mentioned to you guys earlier, the radical or the square root is technically like a grouping symbol, meaning you've got to do what's inside of it. So what's inside of it is we have to do stuff inside of it. So go from the inside and work your way out. So start by doing 2 times 500. So work your way out from the inside. So 2 times 500, well, that's 1,000. So we have 1,000 divided by 32, and then the square root of all of that. So we still have that. So now you just have to figure out what is 1,000 divided by 32, and then that is what you're going to take the square root of. So 1,000 divided by 32, well, that's 31.25. So we're talking about the square root of 31.25. Still not done. That radical is still there. That square root sign is still there. But now that we've taken care of everything on the inside, we're now ready to now take the square root of that. So take the square root of that, and you get approximately, I say approximately because I'll explain why in just a moment. I'm just going to list some of the numbers, test it, and you'll see what I mean. I'm just going to list some of them. 5.5901. That's enough of them. So I said approximately because technically, guys, anytime you take the square root of a non-perfect square, such as this, we know what our perfect squares were. We listed them, 25, 36, 49. Anytime you take the square root of a non-perfect square, that square root is going to be an ugly decimal. It's going to be an irrational number. That decimal is going to go on forever without a pattern, without terminating. So we got to stop writing it at some point. That's why it was really important in these instructions. They said round to the nearest tenth. because here the 5 is in the tens location, the 9 is in the hundredths location. So the 9 tells us how to round the tens location. The 9 says round up, so we're going to say approximately 5.6. This squiggly equal sign means kind of equal to, or approximately 5.6. And since we were looking for time, and it was in seconds, we're saying 5.6 seconds. That's the answer to this question. So you can have a formula inside of a radical or a square root. You just have to do it before you do the square root. So take your time, do the order of operations, and even if it's an imperfect square, that's why we're using a calculator, we can go ahead, boom, get our answer just like that. So from here, we're going to move towards talking about, in general, how to estimate square roots in squares, mostly square roots, for using imperfect, non-perfect squares. We're going to talk about how to do these kind of mentally, so you can predict and know what's reasonable. Okay, so at this point you can consider us of being in 11-3B. So now we're going to talk about estimating square roots. What can we do to make a ballpark figure? Let's say there's not a calculator available, or let's say you want to make sure what you got was a reasonable answer. So before I go anywhere, let's remind ourselves, let's list those perfect squares. Now, our goal is for you to be able to recognize and recall the perfect squares relatively easily, using your times table skills, and just to keep track of them. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. I'm running out of room, so I'm going to leave off 169. Okay, so for each of these, when you go through them, we're going to estimate. I'm going to show you what I mean by estimating. So the instructions say estimate each square root to the nearest whole number. That's what it says. So first, we're going to go ahead and make a ballpark figure. So take a look, guys. Square root of 3. Well, that's going to fall in here somewhere. We know the square root of 1 is 1. We know the square root of 4 is 2. So the square root of 3 is right in between those. And you'll notice the square root of 3 is a little bit closer. So here's what I'm going to do. I'm going to write square root of 1 right next to it. Hey, that's number 1. That was on accident. Square root of 1 and square root of 4. I think you guys will agree 3 is 2 away from 1, but it's 1 away from 4. So 3 is closer to 4. So if our answer is between 1 and 2, it's going to be closer to 2. That's what that tells us. So it's going to be more than 1.5. So you could estimate about 1.6. Maybe even 1.7, I'd go that high. So somewhere between there. So you know if that's your answer, it's more than 1.5. It says round to the nearest whole number. So if it's more than 1.5, like we're guessing about 1.6, 1.7, that's going to round up to 2. So we're going to say the answer number 1 is approximately 2, because that is the square root of 3 round to the nearest whole number. So I know it's not perfect, but it was an approximation. Now, if you wanted to be perfect and you took the actual square root with a calculator, you get 1.73. So if you had just done square root of 3 in your calculator, you got 1.73. That was close. We were estimating 1.6, 1.7. That was right around there. So that would still round up to 2 anyway. So when in doubt, yes, you can use your calculator and just round up. But we're trying to make sure you're starting to think of these in your head. So now square root of 8. That one is between, it's right next to square root of 9. And the next one smaller is square root of 4. It's clearly closer to 9. So if our choices are 2, because square root of 4 is 2, and 3, it's definitely going to be closer to 3. So we're probably looking at 2.8, 2.9, maybe 2.7, probably about 2.8. So, but regardless, that's going to round up to approximately 3. That's what that tells us. So now, once again, if you want to make sure you're not crazy and use your calculator, find the square root of 8. Well, that's 2.8. Well, that definitely is going to round up to 3. Now, take a moment to try some of these. I'll do a couple more, but then after that, I'm going to leave you be and I'll just give you the answers to some of them. But take a moment to try some of these. Hit pause. Okay, square root of 26. You could tell that's right past square root of 25 is 5. It's right past that. It's really far away from 36. So you already know that's going to be really close to 5. So if you're rounding to the nearest whole number, that's approximately 5. Square root of 41. Now, that's 5 more than 36. That's 8 less than 49. So that's closer to 36 than it is 49. So it's going to be approximately 6. Now, to make sure you're not crazy, like I said, if you have any doubt, go ahead and take the square root real fast with your calculator. 41 square root, you get 6.40. That rounds down to 6, so we're good there. Now, for really large numbers like, let's say larger, like 152, in my mind, that's kind of close to 160. Well, 160, okay, 160 makes me think 4, but then there would need to be 2 zeros if we were going to use 40. So that's not quite going to work. So here's what we're going to do. For questions like that, there's no shame for some of these. If you use your calculator, I totally don't mind. That's okay. Or some of you might be thinking, well, hey, 152. Well, that might maybe think of maybe 12. Maybe you're thinking 12, because 12 squared is 144, like we set up here. And 13 squared is 169. Well, if we're between 144 and 169, this is closer to 144, which means it's closer to 12. So when we rounded that, we're going to say approximately 12. I just wanted you to know when you're doing these, it's okay if you sometimes don't quite realize the estimation. As long as you realize ballpark figure what's reasonable, that's what I care more about. Now number 10 over here, 0.81. Ignore the decimal for a moment. 0.81. We know the square root of 81. It's 9. So the square root of 0.81, well, let's just throw a decimal on there. So it's 0.9 because in this case it got smaller. So the square root of that is 0.9. And we're not even rounding when we say that. That's the exact answer. But since it said round to the nearest whole number, we're going to say approximately 1. But definitely that's 0.9. And notice 0.81 is smaller. And that's because you multiplied a number by less than 1, by 0.9. So it gets smaller. So that's what you mean by estimating square roots. Okay, so in each of these examples we're going to go over, you should hit pause and try them both first on your own. But as a note, I will give you a heads up. You'll notice that both of them say round to the nearest tenth. That's because both of them are going to be irrational numbers. They're going to be answers where it's just decimals that go on forever without any pattern or terminating. So be aware of that when you go to do these. You're going to be essentially taking the square root of a non-perfect square. So expect an irrational answer, a number. When I say irrational, I don't mean it doesn't make sense. I mean it's just a type of number. So when you do these, make sure you round the way it says to round. So hit pause, take a moment to try these on your own first. Okay, so now the first one's about speed, about sound. It says the speed of sound in the air, that speed we're going to call it the letter C, in meters per second, so just like feet per second or miles per hour, meters per second, that's a speed, at a temperature T, so T is going to be temperature, in degrees Celsius is given approximately by the formula of the speed equals the square root of everything in here. 402, sorry about that guys. So 402 times the quantity of the temperature plus 273. Take the square root of all that. That's going to be the answer. Now, the question says, what is the speed of sound in the air at a temperature of 25 degrees Celsius? Well, 25 degrees Celsius, that's a temperature. So that's going to be T. So make a little note to yourself. You can remind yourself that T is now going to equal 25. T equals 25. So now take that. 25 is your input. You know everything else, so plug this in. See what all of this equals going inside out, doing in here, then this, and then square root. And then that will be your speed. So let's write it down and let's plug in 25. If you think you got it from here and you need a moment to try, you just need a hint of how to get it started, maybe hit pause for a moment, make sure you got this. Alright, so C equals big old giant square root. Now instead of T, I'm going to leave that space blank because we're going to put a 25 right there. I just can't change colors back and forth super fast. So where T used to be, I'm going to put a 25. You don't technically need that parenthesis in this case. It wasn't going to change your answer. But whenever in doubt, just go ahead and throw an extra parenthesis. No big deal. All right, so we've got we got to go inside out. 25 plus 273 comes first. Well, that's going to be 298. So that tells us we're working with the square root of 402 times 298. That's what that tells us because these two add together with 298. Now, multiplying that with a calculator, 402 times 298, we get, still under the radical, 119,796. Well, that's a big, giant answer. So now we're going to do the actual square root that it says to do. So now hit the square root button. When you hit the square root button, you're getting, now remember, I'm going to have to stop writing at some point because this is an irrational number that's going to go on forever. 346.1155, and it keeps going, but I'm going to stop there. So now the instruction said round to the nearest tenth. So the nearest tenth is that 1. So the next one tells you how to round. So you don't even need the 2 5s after. That's why I said it doesn't really matter. You're just going to round anyways. So this one says round down, so that tells us stop there. So that tells us the answer is going to be approximately 346 0.1 meters per second. Meters per second. Now there's different ways to write meters per second. It's a preference. That's what I'm choosing to write it. So 346.1 meters per second. That's how fast that how fast the speed of sound is. The speed of sound at this temperature, that's what it is. Meaning, when they talk about sonic booms or something, or jets going past the speed of sound, like Mach 1, Mach 2, stuff like that, that actual threshold of what is the speed of sound depends on the temperature, because the temperature affects how thick the air is. But that's another topic for later. You'll talk about that in engineering perhaps. But we just want to keep it simple, let you know we now know the speed of sound at this temperature. Okay, so just know that was the speed of sound at that temperature. Now, so that gave you an idea about science, how that stuff works. Okay, so now let's go to number 6. Press pause if you think, because this one shouldn't be as hard, take as many steps as the last one. So press pause, give this one a shot first. Okay, in this one, as we said earlier, you're also going to have an answer. You're going to have to round to the nearest tenth, which means you're going to have an irrational number. You're going to have a decimal that goes on for a while. So we're talking projectiles. The muzzle velocity v in feet per second necessary for a cannon to hit a target that is x feet away is estimated by the formula the velocity equals the square root of 32 times the distance from the target. I was already translating the variables to what they equal. What muzzle velocity is required to hit a target that is 3,000 feet away? Well, hey, 3,000 feet away. That is x feet away. Oh, so 3,000 is x. Okay, so that means x is 3,000. So in this question, you're going to input 3,000 for x and see what you get. So let's start by writing what v equals. So we know that v equals square root of 32 times, but now instead of x, it becomes 3,000. So you first have to do order of operations. 32 times 3,000. Getting out the calculator. Okay, that's 96,000. So we equals a square root of 96,000. So now the next step is to actually do the square root. And that's going to give us 309. Now I'm just going to write a few of the digits. I'm writing 3 when technically you only need to write 2. I'm just showing you it really doesn't matter. Okay, so now rounding to the nearest tenth. The 3 tells us to round down, so it's going to be 0.8. So that means we're dealing with approximately about 309.8. And remember, we were measuring feet per second. So you could say FPS, that's the abbreviation for feet per second. Or some people like to use a fraction version, feet over seconds. Like we talked about rates and unit rates, feet per second, so it works the same way. So that's how fast this cannon has to be going, 309.8 feet per second. So every second, this cannonball is going to be traveling 309.8 feet. That's pretty fast. So that's what we need to know. That's how much, that's what the muzzle velocity required is going to have to be. All right, guys, so this is just another example of using a formula with a square root in it. Big deal. Just know as long as you follow the order of operations and do the square root when it needs you to do it, you're good to go. As one final note, as an aside note, I didn't have any examples that did this, but I want to point out that if you had a formula where you had, I'm making this up, 3 plus the square root of 5 times 4, something like that, you have to do what's in here first, then do the square root, and then add 3. I just want to make sure we're clear on that. Or even if this was times 3 out here, or divided by 3, or plus 3, it doesn't matter. You're going to have to do all of this first, so 20, square root of 20, so 4 point whatever, and then add 3. So just be mindful of the order of operations when we do that. Alright guys, I hope this helped clear up some of your confusions with squares and square roots, and take special attention to think about those examples I mentioned earlier, about how we found the area of a square by doing side squared, and how we found the side length of a square by taking the area and square rooting it. Because again, that's where that saying came from. To square something means to raise to the second power, because that's how you find the area of a square. Good luck, guys.